Alright, well, welcome to Sunday Science, everyone. Glad you could come back and join us for episode number 2. Hope you enjoyed episode 1 with our overview of the Cassini mission. And now that we have passed both milestones of 40-year anniversaries, what better way to give an homage to some of the most incredible feats of human engineering other than going over the Voyager craft? So we're going to start you off with a quick little intro here from JPL, giving an overview of the Voyager craft, and then we'll get into the show.
Three, two, one. We have ignition and we have liftoff. We have liftoff of the Titan Centaur carrying the first of 2 Voyager spacecraft to extend man's senses farther into the solar system than ever before.
The dark room is the center of the universe. It's where we communicate with the deepest spacecraft we have out. We still communicate with the Voyagers. They send us signals every day. You can see Voyager 2 is being tracked both by Antenna 35 and Antenna 36. Voyager has been a real mission of discovery. Every planet we flew by, we got more questions than answers.
I think none of us knew when we launched 40 years ago that anything would be working for such a wonderful long journey. We had hoped that we could reach interstellar space. We reached that with Voyager 1, and we're about to reach it with Voyager 2.
Voyager 1 is the further of the 2 spacecraft, and it's currently at about 13 billion miles from us here on Earth. The transmitters on the Voyager spacecraft are slightly over 20 watts, about what your refrigerator light bulb would give off. So when the signal crosses that vast distance to us, the strength of the signal is 1/10 trillionth of a billionth of a watt, which is the equivalent of 1 divided by 10 with 21 zeros after it.
A real opportunity on Voyager 2, of course, is because we have a working solar wind instrument to measure the solar wind itself. It's currently measuring the solar wind inside the bubble. When it leaves the bubble, it will then enter interstellar space where there's an interstellar wind, which has come from other stars that blew up. And so we'll have a chance with that instrument to actually measure the wind for the first time directly. The wonderful thing about the journey is not just that it's 40 years long, but in fact it's still discovering new things because it's going where nothing has been before. They will continue until they finally run out of power, but they will orbit the center of the Milky Way galaxy. For billions of years, are silent ambassadors.
Well, that was pretty inspirational. Andy, if you're talking, we're not hearing you.
Can you hear me now?
There you go.
All right. I must have sat on my mute button unknowingly. My apologies.
These things happen.
Indeed, they do. So, since you missed most of everything I was saying, I guess I should start from the beginning again, and that it's pretty fascinating to me that actually the Voyager mission itself wasn't actually Voyager when it came into existence. It was all part of the Mariner project originally. So while we were already using the Mariner project to send probes out to our fun little rocky worlds on the inner solar system, we hadn't really created a mission specific to head out into the gas giants. I mean, we had probes, yes, we had all the Pioneer project, but originally Voyager 1 and 2 were actually slated as being Monitor, Jupiter, Saturn 77. So I always thought that one was fun, that a lot of people just don't talk about that. They don't know that it started out as a Mariner, not as its own independent crafts. And as such, it uses a lot of the same technology as the Mariner, actually. And of course, me being real into optics, love researching the camera technology. And what they were using at the time is actually pretty darn awesome. I don't know how many of you remember Vitacon cameras, but Vitacon cameras is what the Mariner projects were using, and it's what's still on board Voyager 1 and 2 as they reach the depths of the abyss. And it's that technology as a whole just kind of has always captivated me, that we figured out a way of putting a photosensitive film on the front of a vacuum tube so that we could relay this much blue, this much green, this much red through a radio signal. I love analog tech. I know it's old and it's outdated and no one uses it, but when you really want to start learning about electronics, and you just have to start where it began. So always captivated me that those cameras are actually capable of doing that, even though they're off now. I just think the technology is amazing, personally. And being Sunday Science, technology is what it's all about. So anywho, so, Voyager 2 was actually launched prior to Voyager 1. And part of the reason why it was dubbed Voyager 2 as opposed to Voyager 1 is that we darn well knew it wasn't going to be the first one to reach the initial Jupiter and Saturn orbits that it was intended to. So, as a mission, we were well aware this was a once-in-a-lifetime window. In fact, it's a once in every 176-year window, I want to say, if memory serves me. So that's a pretty small launch window, and you just got to make sure that you hit it. And even though one might launch before the other, that doesn't mean it'll arrive at its destination before the other. So Voyager 1 being launched second on September 5th, it was actually the second craft. But that really doesn't matter right now. All that matters is what they've been doing and what they've been up to for the last 40 years of interstellar travel. Hey, nothing beats 40 years flying through the solar system, right?
Agreed.
So, now that I actually do have functioning video share, let's go ahead and get this rolling here. So it's pretty impressive. The first time that Voyager sat down and Voyager 1 sat down and decided, let's go ahead and turn our camera on. They were able to capture this absolutely phenomenal image of the Earth and Moon from about, I think it was 7.5 million miles. I could be wrong on that number, but like I say, there's a lot of stuff that you can't memorize everything, so I'm just trying to remember back then. And this image truly is amazing. To sit down and think about the distance necessary and the camera technology involved at the time, it might be a blurry, spotty image. It might not be as crisp and clear as the Discover is, or the Himawari, but camera technology, it's come a long way in 40 years, and a lot of that is thanks to missions like this. Even comparing images like this, going back to the Mariner missions, I mean, Mars looked pretty fuzzy and globby and really not that attractive of a place to go to if you worked off original Mariner and original Viking images. So this really is an absolutely astonishing image and a true achievement of mankind to be able to sit down and get this mission underway with really not much forethought when it comes to when can we do this. It was calculated, I want to say, in 65 originally, that we would be in the right alignment position to actually send these craft where we wanted them. And like I say, as originally being part of the Mariner mission, they were only slated to go to Jupiter and Saturn. They weren't ever supposed to go much further than that. It's just phenomenal that they are still working as well as they're working, and there's been a lot of work from people all over the globe, in fact, to make sure that we're able to continue to communicate with these two craft, and we'll get to that here in a little while. So we'll try and do some more. Oh, that's just not looking that good on my end. How's that look to you, Sai? It's looking pretty small.
A little bit. I got a pretty good image. Can you, no, it looks okay here.
Yeah, hopefully it works out well enough. So, on March 9th, it was a pretty big day for Voyager, March 9th, 1979. It made its closest pass into Jupiter, and for one of the first times ever, we actually were able to get non-terrestrial images of our big brother gas giant Jupiter. And it, aside from taking some phenomenal images, that one, obviously, I mean, there's just, I think something to the effect of 13,000 images. So I'll click on some of the real amazing ones, but not every single one. But one of the other amazing things that the first arrival actually gave us with Jupiter and Voyager 1 were rings. You can't see that Jupiter has rings from any terrestrial observatory. They're too faint, they're too small, and it was pretty shocking that, hey, take a look, Saturn's not the only one. At the same rate, Voyager 1 also discovered two new moons, Thebes and Metris. I'm not always the best with English. Also, obviously, the jewel of Jupiter, the Great Red Spot, was finally confirmed to be a cyclonic storm in the atmosphere. And while it's amazing to watch from Earth, it's one of the greatest things when you're an amateur astronomer to sit down and you can start in the evening and have the red spot in one place. And as you go throughout the evening, you actually do notice, hey, this whole thing's moving. And then I'll look at Jupiter again tomorrow, and it's gone. Where'd it go? It has an atmosphere, and it has wind patterns just like Earth does, just a hell of a lot bigger. So it was pretty awesome when Voyager 1 actually was finally able to sit down and take some of these pictures and start sending this data back, that cyclones aren't an Earth-born thing. They're everywhere. And elsewhere, they are much larger. Also made some great flybys on most of the moons, well, some of the moons that we knew about on Jupiter at the time. Just spectacular images. Again, you have to remember the technology available. While it's grainy and it's fuzzy, you always have to remember these images are made by a Vidacon TV studio camera. They're not... CCDs were a toy in the lab. Film cameras, you weren't exactly going to sit down and try and continue on with the process of let's try and develop film on a spacecraft and then scan it and send it back. So a lot of Voyager 1's images are a testament to what we were able to do when it comes to sitting down and actually using the technology at hand, taking that leap forward, and almost getting into the digital photography age before CCD technology was readily available. Like I say, it was in the lab, but all the way functional. Did somebody else join? I didn't
Yes, yes. Lord Crocosquirrel joined us. Welcome.
Ah, Lord Quackasquirrel, welcome. Glad to have you with us. So, it was early July '79. I want to say Voyager 2 finally showed up, and it confirmed, without a doubt, as it shown earlier, Jupiter has rings. One of the other amazing discoveries that Voyager 2 made when it finally got to Jupiter was everything that was happening with Europa. You know, well, of course we'd been viewing these, Galilean satellites for a couple of hundred years. There were lots of questions that needed to be asked, and there were not many answers at the time. And the surface features on Europa, which I don't have a link to the pictures that I want right now, so you'll have to bear with me. But it was pretty obvious that Europa had a very active surface, and that it wasn't something like our moon or Phobos and Deimos. It was actively recirculating itself and being a frozen.
It was in fact really, really, really cold down there, which is another thing they hadn't expected. They expected Europa to be rock, not ice.
Indeed, you would always assume. I mean, knowing what we knew from the inner solar system from the Mariner missions, why would you assume anything else?
Because it's already orbiting a gas giant, you would think it would be made of something a little different.
Exactly.
Most of what you're going to find out that way is either going to be you're going to find cryo gases, maybe in gaseous form, and maybe you're going to find things like hydrogen ices. You get far enough out, or you're going to find with very little else in terms of resources. You're not going to find a lot of iron out there, for example. And
Indeed.
I want to see you try and find gold or uranium out there. It won't happen. Or it will happen in very, very, very tiny amounts.
Yep, exactly. There are certain, there are certain things you just don't expect to find, so when you do find them, it's an absolutely amazing scientific endeavor.
Mm-hmm. If they had found that Europa was entirely rock, that would have been a thing.
Indeed. One of the other awesome things that, so back to '79 when Viking 2 arrived, it was pretty awesome to find out for the first time, since certain other missions hadn't gone all the way through, we finally found signs of volcanism on alien worlds. And this was the first time we had actually come to that. We hadn't witnessed volcanism on other planets yet. We would eventually on multiple other solar system planets. But at that point in time, volcanism was an earthbound creature. It wasn't elsewhere. So there were a lot of amazing discoveries made by Viking 2 when it arrived at Jupiter in '79, and that information is still something that we're sifting through. It's not information we're just going to sit down and go, oh, here's a radio signal. Okay, I know that. Got it. We're done. Let's move on. It's years of work, years of studying the data sets.
Doesn't quite work like that. Yeah. No, Io was the place where they found the most obvious volcanism. And they actually got a look at it from Voyager, and then they got an inkling that it was going on by means of Voyager when it came past, and then when Viking actually got into the correct neighborhood, they actually got a chance to go and have a look. The Cassini probe was looking at that last I heard, and there's lots of stuff there. Europa does an outgassing as well. Can anybody tell me why these things happen? Do any of you know? Well, I'm pretty sure Andy knows, and I'm guessing Strike should know. But how about you, chat? How many of you know why you might have volcanism in those places where you don't have it in places like, say, Pluto? which is resurfacing very quickly.
Yes, Emma.
Yes, Emma, that would be correct. Tidal heating. What it's doing is when they because of the resonance between Europa, Io, and some of the other moons, and Jupiter's gravity is just kind of kneading the inside of it from the other side. You get the moon. You get a moon in the correct position, and then you get Jupiter, and it just kind of works that up.
Well, there's what is it with? There's another real interesting one with Io where it's actually helping to juice Jupiter's magnetic field, and that had never been witnessed prior as well. So it's it's dumping hundreds of amperes of electrical current into Jupiter's magnetic field, and again, thanks to Voyager 2, this is something that we had never known was taking place, and now we know that is the thing that can happen.
The magnetometers did not lie to us in any way, shape, or form. And you will find that there are quite a number of creatures that would deny it ever happened.
Well, shames for those. Anywho.
Yeah, well, we were talking about Jism just a few days ago. Because apparently for him, electromagnetism isn't actually a force. It is 3 or 4 different ones.
Yeah, they can have fun on their shows, and we have debunking shows for that. This one's about what's real.
Yeah.
Yep.
Yeah, it's a little more.
Jism's all
more
fake.
Serious.
No worries.
Agreed.
So moving forward, though, it's early November of 1980. Again, I'm pulling a lot of this stuff out of the back of my head from studying this stuff earlier. So if I'm off on dates, feel free to call me out on it. I don't care. But I believe it was early November of 1980 that Voyager 1 finally reached Saturn. And one of the fun things that it did from, again, my recollections, is it actually took a look at Titan prior to getting its closest flyby of Saturn itself. Because, again, Titan, with like so many other moons, we were aware that there was some sort of an atmosphere on it, but what was it? Why did it glow the way it glowed? And
because that was a really nice.
It was pretty phenomenal comparatively to Venus. That, of course, we had already seen with Mariner. Venus has got an atmosphere, and it's got a toxic, deadly, horrific atmosphere, and it likes to crush spacecraft. So yeah, let's not do that. But let's take a look at Titan, because it also has a nice thick atmosphere. And it happened to be incredibly nitrogen rich, which that was the first. It was another first. The number of firsts, the number of achievements and accomplishments of the entire Voyager mission are just absolutely astonishing. It, with my telescopes at home, I've seen Titan, and I don't have an observatory. I'm not a professional astronomer, but I've seen Titan orbiting Saturn. I know it's there, and I know it glows too bright, looking at it with my naked eye, to not be something more reflective than a chunk of rock. Because I can look at Mars and never see Phobos. Not once. Maybe someday I'll get lucky and see a bit of an eclipse, but my telescopes are not that big. Yeah, it's minuscule.
Compared to the massive brightness of Saturn, Phobos isn't there.
It's more of an
serious resolution to get that. Well,
oh yeah,
Phobos and Deimos are actually both captured asteroids, and you can look at their orbits to determine this.
They do have pretty irregular orbits and irregular shapes as well. They're nowhere near spherical in any way.
No, because they're not that
weird, lumpy chunks of leftover crap that got sucked into Mars.
Well, there is actually evidence that Mars has done this a lot, and every so often, even modern probes are finding skid marks from objects that just Mars has decided it's going to eat.
It does seem like the Mimolite is very close to the asteroid belt. It makes sense. The larger gravitational object is going to pull in the other objects. It's
the little guys.
Really not that weird.
Well, it's not that weird, But the idea that Phobos and Deimos have survived as long as they have is apparently Mars had quite a number of other moons at later times, or excuse me, in earlier times, and it's pretty much just decided to snack on them occasionally.
Emma, the angry red planet.
Yes.
Why else would it be red? Of course, it's red because it's angry.
Indeed.
Yeah. It's like that one Angry Bird. Red? Yeah. That guy? Yeah, it's kind of like that.
All right, one of the other fun things when Voyager 1 finally got to Saturn, one of the things I thought was really interesting, in Claudius was, we knew it was there, but it was way too bright. When Voyager actually got there, the damn thing was way too bright. And after having seen what we had seen on Europa, it was pretty obvious that we're glad we launched 2 probes, because we're going to need a second one to take a better look at this thing. What is going on? It should not be that bright.
What is going on?
So come August.
It was what we wound up with was a nitrogen-rich atmosphere that was packed full of hydrocarbons. And in fact, liquid natural gas on the surface. You have lakes of that shit. It's brilliant. Yeah, that was. We found out about that a little later. I'm sorry.
A little bit. So yeah, come August of '81, Voyager 2 finally arrived, and it was able to actually start doing some surveying on Claudius. And not only was it geologically active, but it seemed to be replacing its own surface within months. So, well, Cassini. We needed a better look even still. Voyager 2 gave us a decently better look than 1, but it still wasn't quite enough. So the Cassini mission was born and started coming into existence. What else are you going to do? Which,
you don't have a choice.
I'm still screen sharing. I should not be on Jupiter anymore. We're on Saturn. What am I doing?
Woohoo.
Oh, good grief. Is this really going to do it this way?
Absolutely.
Of course it is. Oh, good grief. I'm going to stop sharing for a second. Hold on.
Okay.
But yeah, we're gonna catch all kind of crap from the science deniers, because we don't know what these things actually are. You can't say that. They're going to ask us for evidence when they won't give us any.
Well, of course.
Well, again, another one of their losses. Ah, there we go. Lord of the Rings. That's the page I wanted to be on.
I've never made that reference, Lord of the Rings. Nicely done. I never thought
Very
of that.
nicely. I approve.
Okay.
That's how... That was actually taught... Oh, man. I can't remember how many years back. It's been enough that I don't remember how long ago, but... That's how it was first described to me, was Lord of the Rings.
That'll keep it memorable, I would say.
I agree. That keeps it very memorable. I would encourage this for everyone.
Indeed. And I mean, these images coming back again, I know someone's going to wind up getting sick of hearing me talk about camera technology, but you really have to be impressed with the fact that this is an assembly of, we need this much blue, this much red, this much green in a radio signal.
Mm-hmm.
This is
per pixel.
Obviously, people, this day and age, they love, oh, CGI this, and oh, bullshit that, and well, no, this is a radio signal.
And these were cameras that were designed in 1971 and 1972. The designs for those cameras are older than I am. Not much else.
I mean, the designs are old, but it's technology that works, and it's technology that had already been proven to work. So why wouldn't you keep using it? Like I mentioned at the beginning, Voyager 1 and 2 started out as part of the Mariner project. They weren't Voyager until they were about ready to launch, and the entire thing was renamed. They would have been Mariners otherwise, and they were running Vitacon cameras as well, and there were TV studio cameras repurposed, refitted, and reconstructed and rebuilt to be some of the greatest imaging we had ever seen of the solar system. It's the stuff that we're willing to do to go and look at something. I love it.
Part of being human.
We can do it.
We are a curious species.
Yes, we are.
Indeed,
we are. Terrifyingly curious creatures.
This is always a good one too. The filter sets that were on those. There was, oh god, what were there? I think there were 7 different filters on the wide-angle lens, and
that one there is the gas chromatograph. Yeah.
So I mean, not only were there 2 cameras, obviously there were other means of imaging things. There were also I think there were 2 spectroscopy instruments aboard each craft. I can't remember again, though. I think it was 2 different types of spectroscopy.
Yeah, you have radio and, if I remember right, it's radio and gas, because you can look at radio signals.
I think so.
So what they did was they took the radiation emissions that came from Jupiter, and then they turned it into sound, and it was as it was beamed back.
Yeah.
Jupiter, Saturn, Neptune, and Uranus all have their own little song.
Oh yeah. Some of these I just.
Yeah, it was. One was we had radio spectroscopy.
Unbelievable.
Spectroscopy and gas. Radio and gas. And
hopefully, I need to find a picture of this real quick, because Voyager. No, they're not going to have it in this particular album.
Probably not.
Anywho, with Cassini, we've all seen it so many times, I probably don't need to, but it was actually Voyager 2 that first discovered the holy hexagonal storm Batman. What is going on the North Pole of Saturn? And it was a stitched together, 20 some odd images stitched together in order to actually show what was going on. It
actually looks like a hexagon.
The hexagonal storm is still kind of still mind-boggling. What in the world is going on with that thing?
Actually, I think
it is. It's never.
I think what that is you've got storms going on around it, and that's just a reasonably calm section that is just sitting there because rotation.
Indeed.
That's me. That's me thinking. That's not necessarily me being absolutely correct, but that's what I'm pretty sure that's what I heard.
Smaller storms on Saturn, again from the same imaging system. Just so I mean, these were all firsts for their time. A lot of this stuff had never even been attempted prior. I mean, all of these cameras, all of the spectrometers, these were all made specifically for this one mission, not even knowing what they were going to encounter, not knowing how, how are the magnetic fields of something this large going to affect it? Are there more rings around Saturn we can't see? Which, oh, by the way, yes, welcome F ring.
There were. Yes.
And
hello.
Not only welcome F ring, but welcome the fact that there are actually moons in the F ring that are helping to keep the F ring intact.
Yeah.
So they're not only there, they're being kept there. Something, there's here are captive moons that are making sure that the Lord of the Rings has even the F ring, as faint and tiny as it is, and probably should have covered that more in last week's episode, but whatever.
We should not make Artie come in here.
Anyway, and apparently the rings were nowhere near as organized and contiguous as we thought before we got there to image them more closely.
Oh no, the closer we got, the more chaotic and erratic they became. Some actually almost looking like bicycle spokes.
Indeed.
Yeah. There was lots of fun things in there.
Well, a cluster F.
You almost got non-family friendly there.
We're family friendly here on this version of the show. I remember hearing that.
Hey, I said cluster F.
Yes.
We were talking about the F ring.
That's right. Exactly. Well, that's
right.
It's a cluster of moons and other small objects held by gravity in place. It's working out for them pretty good, I think.
Mm-hmm.
It keeps making that planet. The main thing that I need to get this new telescope up. I've been so shrouded by smoke the last few days, I haven't even wanted to work on it because I can't see through the damn sky. The smoke is so thick right now.
Oh, where are you at?
I'm just south of Denver, Colorado.
Oh, wow. My condolences.
So we've been catching a lot of smoke lately, and
well, we've had smoke blowing in from the east. We've had ash blowing in from the east here. So go figure.
Right.
Yeah. The ring of fire is literally on fire.
That's one of those joys of living where there's pine trees.
I know, right? What's up? It's not. They're nice during the winter because they will hold the snow up off of certain spaces, but after that, not so much. Then they burn way too well.
We've been lucky in New Jersey. We've got the Pine Barrens, and fortunately, they've stayed relatively on fire.
That's always good.
We're happy about that. Anyway, Saturn's one of my favorites to look at through the telescope.
Yes,
I can never get enough information about it.
It's absolutely gorgeous.
And yeah, even through a small telescope, if a 5 or 6 inch reflector, when it comes into sharp focus, first you get the feeling you could reach to the front of your telescope and just grab the damn thing.
Right.
Secondly, it's now the rings look smooth and contiguous from here, and we learned that's not true. But truly a beautiful object.
Even with just a decent pair of binoculars. I mean,
if you know what you're looking
obviously,
for, where to look for.
I would suggest the telescope. And personally, when it comes to viewing planets, I would definitely suggest a refractor, not a reflector. But that's my personal preference. So,
well, we're in a short town, so smaller is better. So a reflector can be a lot smaller. So.
Well, and you can get a much larger reflector for the price point than you can even a good 180 millimeter. No, wait, I'm thinking backwards. A good 80 millimeter triplet is going to be twice as much as a 180 millimeter or 200 millimeter reflector. So, you got to choose what you want to do.
I use what I got. Anyway, sorry to interrupt. I was just thrilled with Saturn.
Oh no, you're fine. It says here Saturn and 3 moons. That is actually wrong. The 3 moons that they're talking about that they marked on the image here are correct, but you actually have a moon that's currently transiting that they don't seem to have noted.
Indeed.
And we did. We win.
I'm not sure which one that is. But I see it. It says
I can generally name Galilean moons looking at the planet through a telescope, but Saturn's moons I can't. Other than Titan, the thing just doesn't look right. It shouldn't be there. Obviously, hence why it's such a study interest.
Mm-hmm.
Yeah. So, anywho, obviously, with only being slated to do Jupiter and Saturn, at this point in time, the Voyager missions had effectively done their job. So, what was next? Voyager 1, see ya. They decided, upon extending the mission, up, and away for Voyager 1. So it headed above our general plane that our planets orbit on, and it's on the same track that it's been on ever since then. That was, 1981? It decided, we decided we're going to shoot you out and let you go into space.
Now, is one headed at Polaris?
No, it's
No.
it actually went north off of the celestial plane, and it's just kind of going out that way.
Yeah,
Or off the system's ecliptic. It went kind of north, and it's headed out that way. It's not actually headed for Polaris. It will probably. I'd have to look again, but yeah, it's actually not on our plane.
Yeah,
and
it's no longer in the solar system plane.
The thought that it might actually be able to intercept Pluto at some point was completely dashed. There was that thought, and it didn't wind up happening. Because I remember all this.
Pluto's had such a rough history. Poor little guy.
Well, they still managed to catch it with New Horizons, so it can't have been all that bad. That being said, I was just short of my 10th birthday when all of this came around. When we started getting shit back. Yeah.
Yep. So, January 24th of 1986, where were you then? Because I know where Voyager 2 was.
Where was I when?
January 24th of 1986. Because Voyager 2 entered its nice little trek with Uranus at that point in time.
Yay, it's my favorite planet.
And boy, did it find some moons. Holy freaking crap, they were everywhere.
No shit.
Actually discovered 11 moons. 11 moons we had no idea existed around Uranus at that point in time. I don't have the names of all of them, nor do I want to try and memorize them.
Probably hunt them down, but
I'm sure someone can look it up, but
you got to be a Shakespeare
right now
specialist.
I need to it's gonna do this again. I don't know why okay, I'm stopping sharing again. Hold on.
Okay.
I don't know why this is happening this way. This is stupid.
For the record, I was in Grafenwold, Germany. And for television, we had AFN. And AFN was very good about covering it all.
Oh, what the hell? Now I lost all of it.
Oh, that's no fun. Can't have that.
That's never any fun.
No. Yeah, how's it?
I'm surprised we don't have RJ today.
I thought I saw him in the comments.
How's your Shakespeare, by the way, if you're going to go into the moons of Uranus?
My Shakespearean is not strong.
Okay, well.
My Google flu is much stronger.
Oh, okay then.
Okay, well, I just lost it. But anyway, yeah, so, 11 new moons, never been discovered. One of the... While I start typing again, one of the other things that... I really hope that we send more craft out to Uranus, because, to my knowledge, Voyager 2 is the only one that's actually been there. And this whole sideways-ass magnetic field... Excuse my French. We need to do more research into that, because Yeah, sorry, I'm trying to type and talk. It's not working. I'm not a multitasker.
We're following you, though.
All we know there is that something happened, and Uranus is actually on edge.
Yeah, the planet's on its side, and the magnetic field...
The damn thing's sideways.
Yeah, and the planet is sideways, and the magnetic field is not even aligned with its axis of rotation. So
nope,
it's not.
But that is...
its axis of rotation and its magnetic field are not one and the same.
Yeah, that
they're
is
nowhere near it, in fact.
And
they're almost 90 degrees off.
That little mystery is why Uranus is pretty much my favorite planet. Even though I love the looks of Saturn, Uranus is the one. That little mystery is the one that drags me in.
Oh.
Alrighty.
All right, let's see if I can get this. Why in the... Sorry, I got a new laptop and it's a touchscreen. It's filling me insane.
Well, then you still have a mouse and a keyboard that you could use properly.
Indeed.
I do, but even the little touchpad for the use a mouse on a laptop is touch sense. It's like
Oh, I turn that
brush
tap.
your finger over it
Oh,
sensitive.
I turn
You
that
need to
tap
turn that off.
and that tap stuff. No, I don't do that. No, I'll click the button. I'm not doing that double tap on the pad. There'll be none of that.
Okay.
Yeah, that drives me absolutely insane.
Pleiadius,
So,
okay, from
now
the
I can
chat,
go back.
Pleiadius, I would suggest that you might actually be right with that. We don't know, and that's kind of the thing.
Ah, there it is.
There we go.
That's the image I wanted to share. Nothing makes a crescent moon better than a giant ball of ice.
Yeah.
Especially the coldest one in the entire solar, one of the coldest places that we've ever actually measured temperatures, period. Colder than Pluto, colder than Neptune, colder than most stuff in the Oort cloud we've had basically no ability to measure so far because, yeah, we only have a couple of things out there. We're talking about them.
New horizons, yeah.
But, yeah. 59 Kelvin? I remember pretty much, it was basically as close to absolute zero as we had actually measured when Voyager 2 got to Uranus.
Mm-hmm.
And I'm still blown away with that. Why in the world is it so much colder than everything else?
Because it's a big-ass ball of ice.
Still. Okay,
Still.
There's a possible
It's actually
explanation.
colder than Neptune. It's closer to the sun than Neptune, but it's colder. Why? What in the world is actually taking... Well, not what in the world, but what in Uranus is taking place to making it that cold? It's ruining my colder than a well-digger's ass jokes.
Do it.
Alrighty.
See, that's just it. We have no idea. Well, I don't know about a high albedo because it's not actually pure. It's not purely water ice. Most of Uranus, as far as I know, is actually methane.
Primarily methane, yeah. And obviously, for methane to become a liquid as opposed to water, you're talking a
Much colder.
huge difference in temperature. But yeah, one of the other awesome things that came around is as soon as Voyager 2 actually got to Uranus, there was some pretty interesting other things that were taking place as opposed to cracking jokes about being cold. It was the first time that we actually tried getting the entire DSN or Deep Space Network to come online. And it was a collaborative effort, and this is why I said earlier on, it's so amazing that when it got into its later years, and still even today, this turned into a global collaborative effort as opposed to these people over here are going to do this. It became a worldwide almost sensation that we're finally there. We're out there. We're seeing the ice giants for the first time. We're measuring them. We're getting data based on what this instrumentation can do, and we need more. And as they said in that JPL intro that we played, the radio signal, not just the radio signal degradation, but you have to think about the fact that once they got there, those cameras originally, it was advised never to do an exposure longer than 15 seconds or so.
Mm-hmm.
And they were having to do almost 4-minute exposures. And these aren't autonomous cameras. They are not autonomous cameras. So someone was having to sit down in the dark room over at JPL and go, okay, send that signal to move this much now. All right, let's wait 15 minutes. That's when we're going to see the results. You know, so someone was physically doing that. They weren't, you know, it's not like anything going on with the Curiosity rover. It was completely different technology at the time, and there was a huge lag in between command and action. So to get these kind of images once we got out there, not only is the imaging absolutely phenomenal, but everybody else's work, which, being an American, I really have to go ahead and toss my hat out and say thank you, Australia and Spain, because Space Network with us. And without receiver dishes in their countries, we wouldn't have the Deep Space Network, and we wouldn't still be talking to these guys. Or gals, or whatever. They're machines. They don't have a gender. I don't care. We wouldn't be talking to them either way. It would be too difficult. The signal strength is too faint. we wouldn't be able to send commands to them to keep taking pictures up until almost the 90s. It's absolutely phenomenal that so many people around the globe came together to work towards, let's make this keep go. You know, it's got power. We can keep doing it. We can keep getting radio signals back from it. This is important, and we need to do it. And so they did.
Indeed.
Well, until of course they can't. Until of course can't do anymore, because sometimes that does happen.
Well, and you know, eventually they won't have any power, but we're not quite there yet. We're not even to Neptune yet.
Well, and
actually, we're about to get to Neptune. I'm talking about in the show, not in what we've done.
Yeah. Oh, by the way, I was doubly wrong before. I don't know how I screwed it up. I said Polaris instead of Sirius. That was just a brain fart. And that was Voyager.
Yeah,
that was Voyager 2 anyway. That's where Voyager 2 is going, not 1. Voyager 1 is going to AC-79 and Camelopardis in a very long time. That's Polaris. That would be a hell of a turn.
Yeah. That turn would be really. I don't think you got enough fuel for that, man.
No.
No.
Anyway,
especially knowing the entire fuel source isn't. I mean, it's not like they have combustible fuel. They don't have solar panels. It wouldn't work.
Well, it's just it's monopropellant and a little bit of nuclear power and a little bit of nuclear power source. Period.
Yep.
Indeed. It's all heat transfer.
So, indeed. So, come August of '89, finally, the first time we ever actually got pictures of Neptune up close and personal. I don't think we were expecting it to look exactly how it wound up looking.
Big blue.
It's pretty phenomenal knowing that Voyager 2 was only slated for Jupiter and Saturn, and it spent 12 years traveling through the unbelievably boring void of space. It was finally able to do one of the first things ever and get imagery of Neptune. And sure, not all of it was the most awesome, but scientifically awesome.
Indeed.
By far, obviously, one of the one of the most amazing parts, you know, aside from, once again, there's a ton of moons, and guess what? Neptune has rings as well. Seems all the gas giants have rings. And more moons than we can count. But it also had the Great Dark Spot. And that's something you can see from Earth observing at the time. And I mean, you can barely even see Neptune with an amateur astronomer telescope. So making out surface features, good luck.
I don't know. Laplace managed to figure out where it was within 1 degree of where it was actually found.
There are observatories, yes. I'm talking about amateur astronomers like myself. You're talking about 6 to 8 inch apertures. Maybe I'm building a 20 inch, but
yeah, Laplace didn't have anything that big. He was actually working with raw mathematics and the perturbations in Uranus's orbit. That's all he had. No observations at all. It wouldn't be found for another about another 100 years. It was well after the guy died. It was found within 1 degree of where Laplace said it was going to be. I found that when I spotted that in the history book. Yeah, there you go.
Well, there are lots of discoveries made. There are lots of discoveries to make. That's pretty much all I know. As long as we keep with the science. Here's a better one.
Yeah, there you go.
That's a much better image of the Great Dark Spot. And one of the things I thought was cool about the Dark Spot is its kind of come and go attitude. It doesn't seem to want to stick around too long, but it always seems to want to be there. It wants to be imaged. It wants to be pictured. It doesn't always want to be in exactly where you want it to be.
Sign up at 888casino.com and get $20 free for playing with no deposit needed. Experience the
Somebody's running a video.
What the hell was that?
I don't know. Wasn't me.
That was interesting.
Indeed. Anyway, okay,
Anywho.
yes. Great dark spot. Yep.
The flat earthers are trying to get.
Back
The flat earthers are trying to disrupt us.
Maybe so.
Everyone, run away!
I wonder if
they found us.
Do we have any images of Spot 2? They could have thought up. They could have thought up a better name for that one, don't you think? Spot 2. They really looks like an eye. Why couldn't they say something like that?
Right.
Because Spot 2. Everybody wants one named after their damn dog. You know, Spot 2.
Well, anywho, after having gotten to be the first craft to image Neptune up close and personal, Voyager 2 finally decided, or I should say we decided, Voyager 2 should take its final image and move into darkness. Surprisingly, it takes a little while to actually turn off cameras that far away. So it was between October and December of '89. I don't know. Again, I don't know the days. I just kind of remember the months. It was between October and December that Voyager 2 finally fell into darkness. Obviously, with the mission continuation, they needed that energy reserve for doing other things, and there was... Well, they weren't going to run into anything else worth taking a picture of, so... the cameras on Voyager 2, the cameras have been off since '89. There's really no reason to even think about turning them on. There's much more useful information that they've been continuing to send. And shortly thereafter, I need to make sure that I find this one and bring it up. Oh God, it's gonna do this crap again. Whatever. I'll keep sharing even though it's annoying and doing this stupid thing.
It's because it hates you.
It does hate me. That's what it was going to do. I knew it. All right. I'll be back. Hold on.
Okay. These things happen. Not to worry.
I don't know why it keeps trying to close out completely from where I was. It's incredibly annoying. But in February of 1990, one of... personally, I think the most amazing pictures ever.
Andy, Dakota
Pale blue dot.
Dakota wants in. You got room on your panel?
Sure. What the heck? Hop in, Dakota.
He's going to be here for the last 3 minutes, but
right. It happens.
Hey, it's all good.
Here we go. Here you go, Dakota. Oh no, that's for the live chat. That doesn't look so good.
That's okay. We still have to. We still have to do our. We still have to do movie night.
All right.
Or the continuation of movie night.
Here we go.
Yep. There we go. Oh yeah.
The pale blue dot. Our only existing family portrait.
Yep.
Which actually winds up looking not like that.
Yeah.
Once you stitch everything together, but in there you have... Well, you have every planet in the solar system aside from Mercury and Mars.
Yeah, because they didn't want to hang out.
It's... Well, you know, Mars is an angry little bastard, according to Emma, so it was probably hiding. And Mercury was probably too hot under the collar, getting all close up to the sun. Didn't want its picture taken that day, so...
Nope.
Damn.
But I know to a lot of people it just... Ooh, this is a fuzzy, streaked thing. Almost the entire solar system in one picture. And how it is that that actually came to be. How it is that that was all actually taken a picture of, because this was the last picture ever taken by Voyager 1, or last series of pictures. It was the last one. Its cameras as well, just like Voyager 2, they turned off because what are you going to take a picture of? Nothing. It's done. I mean, maybe there are some things, but they're, well, do you want to have the energy to measure the bow shock, or do you want to take a picture of what we probably wouldn't interpret with those cameras? I'll send back the data as opposed to the image.
Well, no, you can find
Speaking of which, what was it? It was 1998 finally that Voyager actually surpassed Pioneer and was like, hey, guess what? I've been in space longer than you now. Yeah, I'm cooler. I'm further away. That was a thing. It happened.
Yeah,
I remember that one pretty vividly.
And there was a bunch of people crowing about it. Voyagers are better than Pioneers.
It happens.
Of course, by that time they were already planning the New Horizons mission, which I found, which I actually
already launched. Actually,
98, yeah. No,
Cassini had already, or no, not New Horizons. Sorry, Cassini had already launched.
Yeah, I'm thinking of New Horizons. It didn't launch until somewhat later. I think it was actually
2003.
2003, yeah.
2002.
Something like that. Somebody could probably.
It was around there. I know. Yeah.
Dakota's in.
Which,
hey, Dakota.
Funny enough, actually, right after it was right after New Horizons launched that Voyager 1 finally did cross the bow shock. So I'm glad you brought that up because, again, that was the thing that happened, and it took us a little while to actually
realize that it had happened.
Realize it, yeah.
We got some of that data back, and all of a sudden we get an intensification of radiation, and we're going, "What is that?"
Well, they weren't actually even listening the first. When Voyager 1 went through the bow shock, we weren't even listening to it. We had our minds set on, that little New Horizons guy a little bit too much. We weren't paying attention to Voyager 1 when it crossed the bow shock. It wasn't until 2007 when Voyager 2 actually crossed it that we were finally listening, and we got that ping. Mm-hmm. Hey, this is a thing happening.
It's happening, yeah.
Yeah, it's a thing. It's happening. It's pretty awesome.
There it is. Howdy. Hey, Dakota.
And then what was it? It was pretty recent. Last couple of years. 2011, maybe. 2012, somewhere around there. Voyager 2 actually broke Pioneer 6's time and space and mission length. It became the longest mission, and it still holds that record to my knowledge. I could be wrong, but oh yeah, absolutely. As long as it sends back data longer than Voyager 1, which of course, I mean they only launched a couple of weeks apart, so let's just call the whole mission an awesome success of longest mission ever.
Yeah,
it doesn't really matter whether it's 1 or 2. They're just headed in opposite directions now.
Well, at this point, we're still the New Horizons probe. You want to know what it took to get the New Horizons probe together?
Oh, that's going to be a show all on its own. That's going to be a show all on its own. Don't need to give spoiler alerts.
Okay, no spoilers. I won't say anything else about it. I will just be there for the history lesson on this, because that you thought the story from Voyager was strange? No, no, that story was way more. It's actually a much shorter story, but it's way weirder.
When it comes to space travel, there's really nothing normal.
Where spoilers are bad, teasers are very good.
Indeed.
We will be talking about New Horizons sometime in the future.
So yeah, well, it was. I think it was early 2013 finally that it was actually confirmed that the cross through the bow shock by Voyager 1 was actually confirmed, and of all things, it was thanks to a coronal mass ejection and the fact that we could map it leaving the heliosheath. And we actually found out, holy crap, interstellar space is warmer and denser than we think it would have been. It was actually kind of hot.
Yes.
For space. Not hot for Earth, but hot for space.
Yeah.
And thick. Soupy. There's a lot more stuff going on. Whoops.
Yes, there is more carp out there than there is in here, because the sun actually had to clear out all of the sun had to clean up all of its shite in order to get itself together. You can't qualify as a
we
star
should have
until you cleanse
Voyager
your
2
local area.
going through the same thing here pretty shortly, so pretty excited to
It
see
won't be
what we're going to
before-
get back from that when Voyager 2 is confirmed. That's going to be a lot of fun.
Oh yeah, I'll be watching that one. That will be very entertaining.
Oh, absolutely.
Agreed. Anyway, hell of a mission. That's all I gotta say.
Indeed. It's been an amazing 40 years for these craft, and the amount of knowledge that we've gotten is just, like I said earlier, it's not going to be something that's completely gone through for another couple of decades. And since it's going to be sending information back until at least 2020, we have another 15 years of studying that data. And it's going to be a while before we have another thing that far out. I mean, New Horizons is on its way, but again, that's a tale for another show.
Yep.
Agreed.
New Horizons will be fun. New Horizons is actually one of my favorites.
Another thing with the photos, when they're this close, doesn't it help them like determine what kind of atmospheres the planet and the moons and the planets have, and like it tells us a lot about it? Because from far away, it's a lot harder to tell, isn't it?
Yeah, that's part of what the spectroscopy instruments on board, both Voyagers and leading up into future missions with Cassini and Juno, New Horizons, they all have spectrometers aboard that are taking those measurements. So while the visual picture obviously helps tremendously, the spectroscopy equipment is actually able to measure what is in that atmosphere. What's the chemical composition?
Kara wants in.
And that is such an important thing.
Hold on, I gotta send a link to Kara.
The,
I was
the thing I'm probably most excited for about just, I don't know.
There you go.
The stuff like this is a possibility of finding. Just imagine if we found like just single-celled life on like a moon, not a planet, a moon. That would like
microbial life on Claudius.
That would imagine. So like, there's probably at least 100 moons in our solar system.
Way more than that.
Way more than that.
There we go.
Way more than that. Because if I remember correctly, Jupiter is considered responsible for at least that many.
Indeed.
Yeah. So
Hi, Kara.
like, imagine, we went from 9 planets, so we have a 1-to-9 ratio of life, and now we found one on the moon. That would just like quadruple the numbers for the chance of finding life out there. Well, first off, we found life, but you'd find it twice in the same solar system, and now you can include moons into the equation at having a chance of life. That'd be crazy. It would be amazing.
Indeed.
Agreed. Kara, sorry for I wasn't watching the chat closely enough. I apologize for the delay in you getting your invitation.
No worries.
All right. Anyway,
I didn't really have any reason to join. Just felt like joining.
That's good enough. That's good enough.
You're always welcome.
That's good enough for me. Anyway,
good enough for most everybody, actually.
Shall we? Let's see. Andy, is it time for simple science or not yet?
I think we're pretty much there. I mean, sure, we're still getting information back on a daily, but right now there's not a whole lot left after the whole CME made Voyager 1 go, my ears are ringing. Something's wrong with the density of interstellar space.
No, actually, as far as life, other potential sources of life inside the solar system, they're looking at Europa, Ganymede, and Io as locations that could actually be of some value in that respect.
Did we get the "all these worlds are yours" message yet? No,
not yet.
Okay, all right. We got to watch out for that.
Yeah, we got to watch.
Right, well,
we got to mind Hal.
I
Anyway,
honestly
if
think
we're coming up on simple science, then I don't need to be sharing my screen anymore. So,
Okay.
Ooh, I'm interested. What do we got for simple science? We had a barometer last week.
Okay, yeah, the barometer was good. And again,
hey, that barometer could have been pretty darn useful to a lot of folk in the southeast United States right now.
I know, right?
And,
well, last week it could have been pretty useful. This week they get
Not
the
so
fuck
much.
out.
Yeah. Well, I will say I see the names in the chat, and obviously the people in the Hangout. To all the big brains out there, I apologize that this may be way below your level. But remember, we're trying to encourage and promote the idea that science is for everyone. And
One moment, please.
Okay.
Just a second.
Okay.
You over there with the ears. Turn. It's my 7-year-old.
Oh, there you go.
He's actually right-handy for this, so I'm gonna hang this up for him for a little bit, and we can watch Simple Science.
All right.
How's that sound?
Very good. Hopefully you'll
Awesome.
find it interesting, and it's a kind of a fun project for parents and kids to do together. This week it's an electrometer. Woohoo! Eventually, all these are going to come together. There's a reason for the order and all that, but here we go. Simple science. What could be better? Hello, and welcome back to another episode of Simple Science. Today's project will be a homemade electrometer. An electrometer is an instrument for measuring electrical potential, or static charge, without drawing any current from the circuit involved. The supplies you'll need for this week's experiment are as follows. A glass bottle with a cork stopper. I got this one at a local craft supply store for about $2. A completely metal cabinet knob with its associated screw and a bag of washers. Some large paper clips. Some aluminum foil. Small pliers with a wire cutter. Scissors. A power drill with a drill bit slightly larger than the screw that came with the cabinet knob. Okay, let's get building. After putting on your safety glasses, use the power drill to drill a hole as close to the center of the cork as possible. Stack some washers onto the screw that came with the knob and push it up through the bottom of the cork. Take one of your paper clips and unbend it to form this U-shape. Use the wire cutter on the pliers to cut the two ends to an even length. Place this U-shape around the screw between the bottom two washers. Screw the cabinet knob onto the screw at the top end of the cork. Tighten it so that it holds the paper clip at the bottom firmly, but not so tight that it deforms the cork. Using the small pliers, bend the ends of the paper clip straight downward. Again, using the small pliers, bend the ends of the paper clip into the L shape shown in the photograph. Take a piece of aluminum foil and cut two thin strips about 2 inches long. Using another paper clip, fold over the top 1/4 inch of each of the aluminum foil strips. This will be the hinge that these strips will swing on. Hang each strip of aluminum foil from the bottoms of the L-shaped paper clip. Then insert the entire assembly into the bottle. You should now see the two aluminum foil strips hanging straight down parallel to each other. If all went well, you now have a working electrometer capable of detecting the presence of an electric charge. But where do we find an electric charge? Remember those balloons we used in last week's barometer experiment? Inflate one and run it vigorously back and forth across your hair. This will generate a static charge. When you rub your hair against a balloon, charge transfer occurs and static electricity is produced. In simpler terms, if you rub a balloon against your hair, the balloon will steal electrons from it, which leaves your hair positively charged and the balloon negatively charged. Hold the charged balloon close to the knob at the top of your electrometer. What happens? Record what happens and leave it in the comments below. Thank you for joining us for Simple Science. We hope you had fun with this week's experiment, and we hope to see you again next week. See you then. That's it. That's what we got for this week's Simple Science. Should be a fun thing to build.
Yay for kidding! I'll wait for the separate one to be pushed up there so that I wait for the separate video to be pushed so we can actually get that one done.
Alrighty. Okay, what else we got, Andy? And
SciStrike.
Yes.
Could you present your screen so we can see your screen on this side, on the Hangout side?
I could, but then it's going to present to everybody. All right. Yes, in fact, I will. Hold on. Here we go.
We have to look at the YouTube side otherwise.
Indeed. Give me a second.
What did he do with it?
Just a moment, please.
There we go. Okay. You should be seeing it.
Yep.
All right.
There it is.
Yay and stuff. All right, so that's Andy. Anything else you'd like to add to this week's Science Sunday?
No, I think we pretty much covered the majority of what's been going on with Voyager over the last 40 years somehow in an hour.
And nice, and nice.
You wouldn't think that that's actually something that you can do, and something tells me we didn't actually do it. But we covered some key points, and
we hit all the high points.
Absolutely.
We did that by skipping the objections that will inevitably come in the comments.
Indeed.
All right.
Because we know what they all are. We just aren't talking about them.
Oh yeah, that's for a Friday night thing, isn't it? Alrighty.
Yeah, there's definitely a difference between Friday night shows and Sunday midday shows.
I know, right? What's up with that?
Yeah, well, Hillel will be happy. He's the one that always asks, Sai, isn't this Science Channel? Well, yes, it is. So, here we go. Does anyone have anything to add before we wrap it up?
Your mother, you're driving me crazy.
No, I think at the moment, I'm not allowed to give spoilers for the other show, so I can't talk about New Horizons, despite wanting to a lot.
Understandable.
New Horizons will be an entire show all on its own.
All right.
Drinking.
Andy. Andy, thanks for having me on your show.
Hey, absolutely. I'm glad you guys could join us, and hopefully everyone enjoyed their time here. In the meantime, take a look for us next weekend. We will be doing a show on New Horizons, maybe not next Sunday. There might be something else a little bit more cosmically awesome than New Horizons to do first. But we will get to New Horizons, and we have a lot of science to talk about here on Science Sunday. So thank you guys all for joining us. I'm really glad to have you with us, and I hope you enjoy the show. Other than that, hopefully we'll see you next week. And anything, again, like I said last week, if there's anything that you want to have talked about or discussed, go ahead and leave it in the comments, and we'll do our best to get around to it.
Mind you, that could be any of us answering questions. And if you're a flat terramite or other space denier, then they'll probably leave it to me to refute and rebut.
I didn't have to call drink once. It's amazing.
It's a different thing on Sundays, isn't it, Cara?
Well, that was the idea. Hopefully we could have a show where you could enter the show and exit the show in the same frame of mind.
Yes. All right. Well,
we seem to have managed to accomplish that this time. I know we're continuing with last week's abomination, the last Friday's abomination, this next Friday. So
yes, well, there was no way it could be handled in one show. There was just too much.
That was too much.
There was too much. There was too much of it anyway. Not the point. We're talking about jism here.
Yes. Exactly.
Friday shows and Sunday shows are very different shows, so
absolutely.
In the meantime,
we'll get back to Friday next Friday. It's actually going to come sooner than next Sunday, so that's one of those awesome things of living on a globe. Friday always comes before Sunday.
State of sobriety. Unfortunately, I'm not going to be able to do I'm not going to be able to much alter my state of sobriety anymore. Not enough shekels, you see.
Understand. All right. Well.
Kara, I gotta give a shout out. Hey, if you want to be on Science Sunday, let us know. You're always more than welcome.
I'd probably just sit in the back anyway.
You're welcome anyway.
But okay, well, I'll join.
And you don't.
You're still welcome if you'd like.
And you don't need the oven mitt, right?
Hopefully,
well,
that's
it depends on the science. It depends on the science. You may need it to handle hot things or something else.
And actually, you would have needed it this show because I did brain fart and indicated that Voyager 1 was on its way to Polaris instead of.
No, not
so,
to worry.
That would have been oven mitt worthy. So, anyways,
yeah.
just a.
That's a hell of a trip, by the way.
Indeed.
Yeah.
Yeah.
All right. Shall we wrap it up, Andy?
I suppose so. It seems to be about that time.
Indeed.
Yeah.
Great. Good job, Andy. Nice work. Nice preparation as usual. And
thank you. Well, you can always go back and watch it again.
I will go back and watch it again.
All right.
Thanks for joining us, everybody. I really appreciate it, and hope you enjoy Science Sunday.
Not the scale.
How in the world would you get it to scale in a single image?
Good question.
Oh wait, that's right. Voyager 1 did that with the pale blue dot. It doesn't look like the solar system though. It looks like streaks and fuzz.
Yes, it did. And it's apparently raining sideways for Brian.
Oh my.
It was Brian in Florida.
Probably, and good luck, bud.
Absolutely.
We'll see you out the other end.
Song. I'm letting it play.
Yeah, I think it's a good song. I wouldn't have picked it if I didn't think it was a good song.
Yeah, good choice. Damn good show, Andy.